Okay, so good morning everyone.
Morning, sir.
Morning, sir.
Today we'll be discussing the continuation of the fish processing, particularly on the fish curing. We are now on the fish drying process. So the fundamentals, methodologies, and the steps and the considerations, as well as the spoilage of drying, will be discussed in this module, which is the module 6. Can I request everybody to turn on your camera? Tell the world I'm coming home. Washed away, washed away all the pain. Iyon sa inyong camera. Tapos, screenshot diha sa inyo. Murag mau pa man mo ng mata. Si Mikmik o mau pang mata. Danilin, si Glisel, di nakakita ninyo mga wayang Renal, Gerson. Kamara kan mag-screenshot kay bagan di makita sa ako. BJ. BJ kay Super Saiyan na.
Sir Chap.
Chappy ako? Okay, 5, 4, 3, 2. Ngisi. Alright, so sakto na. Tulabian mo na yung ngisi. Mick.
Science head, sir.
Sige. Where is that? Makita akong screen. Makita akong screen.
Yes, sir.
Naka full screen na or naka slideshow na? Or wala pa? John.
Wala pa, sir.
John.
Hindi ka ila, sir, pero sa ako, ya pa, sir, di pa full screen.
Dili, sir.
Tell the world coming home. Left the rain, washed away all the pain of yesterday. How about now? You know my
Okay na, sir.
Okay.
Okay na, sir.
Okay na, sir. Okay na.
Sa ako lagi man.
Nag-lockdown na yun, okay nang tanan. So once again, we will be discussing the one of the fish curing process. We are focusing now on the fish drying, which is also relative to our yesterday's topic, which was salting. So in this topic, we will be discussing the fundamentals of drying, the principles on how to properly dry, and what are the do's and don'ts when it comes to the drying process in the traditional way and commercial way. Also, the step-by-step process as well as the spoilage of dried products. Now, as a form of introduction, let us first describe what is drying in definition. So, generally, mag-ingon ra mo kung putol-putol akong tingog ko. Okay, para ma-adjust na to. Generally, drying is defined as the removal of water from the product. So ideally, yesterday, the process or the method of drawing the moisture content of the fish is by way of adding salt. And that's the reason why it was called salting. But today, the primary way of removal of the water is through dehydration and solar drying. Now, we will be tackling specifically what's the difference between drying and dehydration later on. And drying can be through evaporation by the use of pressure or absorbent pads and through the addition of salt. And sometimes the drying process is done through the combination of both salt and dried products, and sometimes just drying process involving mechanical dryers or oven dryers. Now, drying and dehydration are both involved in the removal of moisture. Later on, we will distinguish what's the difference between the two. And drying to moisture content below 15%. This is basically the principles, no? Again, drying to moisture content below 15% moisture content prevents the growth of many spoilage organisms, particularly um, mga halophilic bacteria can no longer grow on that particular environment kung nana siya moabot sa below 15%. And how do we assess, or how do we measure the moisture content of one product? Unsaon nato pag-assess ang moisture content sa atong mga dried products? Naatay apparatus nga specifically designed for that. There is a laboratory apparatus nga pwede nato matanaw, no? But there are also traditional manner nga pwede nato gamiton. Wala tay apparatus nga ingana. Ang ato rang himuon is that we'll get the initial weight of the wet product katong wala pa siya na dry, and then later on ato siyang i-dry dayon through mechanical dryer or oven dryer, or ipasughan ra sa suga. Tapos i-measure na po na nato ang iyang final weight, and that's how we assess the moisture content of the product, the traditional manner. And when our product reaches 10% moisture content, the mold growth is completely suppressed. Meaning suppressed is that dili na mag-occur or ma-prevent na gyud siya, ma-suppress na gyud siya. Okay, so 10% ang moisture content, ang molds can no longer grow. Now, here we have the difference between drying and dehydration. Again, drying is technically defined as the removal of the moisture content, like the exposing the fish and other fishery products to the heat of the sun. And that's the reason why solar dryers are basically covered with nets and some other covering. It's because remove or to prevent the insects from coming in and touching the product itself. So, kung kabantay mo sa nauna, katong bago pa mo diri siguro, mga first year pa mo, there was a solar dryer sa likod sa BAT room, but naguba na siya siguro pag abot ninyo. But technically, kato siya nga solar dryer was supposedly used for the meat processing drying, the drying for feeds, and drying for fish. So technically, the solar dryer uses sun as a form of heat by removing the moisture products or the moisture contents. That's basically the traditional manner of drying aquatic products. In contrast, dehydration means removal of moisture with the use of mechanical device, which controls relative humidity. So yesterday we have defined what is relative humidity. We have defined high relative humidity, low relative humidity. In this manner, the dehydration manner, it uses mechanical dryers, sometimes in the form of mga oven dryers. And I just remember that I have given you a task in drying aquatic products nga pwede mo mag-dry pinaagi sa solar drying. Pwede po mo mani sa eskwelahan, ask a permission to use the oven dryer. Perhaps I will be calling all of you to be here by mga basig next week, tapos ako mong ipagamit sa oven dryer nga nasa ato ang laboratory. Kaya para makamalupon mo unsaon siya pag-operate. Okay, so ideally the difference between drying and dehydration is that the mode of or the source of heat to remove the moisture content is different, no? Ang sa solar dryer is from the sun, and dehydration is from the mechanical devices, and sometimes oven dryer, and so on and so forth. Now, when we talk about drying, we must not forget to consider the water activity. What is water activity? Water activity is basically the ratio of the vapor pressure of the product to that of the pure water. So measuring this determines the amount of free or available water needed to support biological activity. what's very important here is that the water activity defines or determines how much microorganisms could inhibit in your particular products. So kung taas ang imong water activity, there will be also a high tendency that your product could be inhibited with the spoilage organisms, particularly bacteria and some other molds and fungus and other parasitic bacteria that may harm the consumers on your dried products. So, say for example, we have here the food. No? You can see here in this figure the food itself. This is a food basically, and the water activity outside the environment. This is basically the water, no? So when you measure the water activity is basically equal to the amount of water in the food and the amount of moisture that the food could support in order for the microorganisms to grow, no? So again, the ratio of the vapor pressure of the product to that of the pure water. So that muna siya definition. So sa sunod kung magkuha mo water activity sa isa ka product, dili na mo mag-calculate pa kinin na inyo ang gamiton nga device. So perhaps this water activity meter will be acquired in the water testing laboratory because part of which is the chemistry laboratory. For sure, kini siya nga device will be housed in the water testing laboratory. Pwede yun ninyo magamit sa sunod kung mag-laboratory activities sa post-harvest, no? Kung maabot na to by the third quarter of this year. So, when we consider or when we talk about water activity, there are threshold measures. When we say threshold measures, there are distinguished or distinct ranges of water activity that a certain spoilage organisms could thrive. Na po iyang level nga dili na siya maka-thrive. Now say for example, the water activity of 0.9 or below, ang kana siya nga level, most spoilage bacteria will no longer grow. So your product is safe when it comes to bacterial invasion or bacterial infestation. Now, when it reaches for about 0.8 or below, all molds are inhibited. Ang mga molds kana ganing mga makita nato sa kung natay mga bread unya din nato ma-consume. Kanang mga cottony parts, kanang mga murag gapas nga mangrow mo na siya gitawag nato mga molds, no? So kana siya nga level is basically ang iyang moisture content ana or ang iyang water activity ana is above 0.8 water activity level. So below 0.8, the molds will no longer grow, and that's the reason why kung natay mga uneaten products atong ibutang siya sa low temperatures or colder temperatures so that ubos pud ang iyang water activity. Now if our water activity falls beyond or below 0.75, most halophilic microorganisms will no longer grow. Again, halophilic was defined yesterday by Jaya. According to her, halo means saline, philic means loving. So all organisms that are saline loving or that loves salty environments will no longer grow in this level. So I hope that's clear. Now let's proceed to the other fundamentals of drying, which is basically the moisture content. Earlier, ganiha is water activity. Second thing to consider is the moisture content. How do we assess the moisture content? How this moisture content could be expressed in terms of the wet and dry bases? And how do you assess the moisture content when it is salt-free or fat-free bases? Now, there are technologies that basically measure the moisture content of a certain product. One of which is this one. So, moisture content meter. Basically, what you are going to do here in this device is that you just get the flesh of your products, no? Imo siyang himay-himayon, gagmayon mo siya until it forms amurag mga grates, mga kinudkod na siya na mga itsura, and then you close that out kanang kini siya nga taklob, and then this device will automatically measure the moisture content level of your sample. So this is probably one of the easiest manner of measuring the moisture content, particularly if you engage in research on sensory evaluation and proximate analysis of aquatic products or processed products. So ideally, moisture content is commonly measured by drying the sample for 24 hours at 105 degrees Celsius. So that's basically the range of time that you are certain that moisture content will be removed in that particular range of time. Okay, so that's second, the moisture content. Now let's proceed to the phases of drying. There are basically or generally two phases of drying. By the way, namat madunggan pa ko dili na.
Okay pa, sir.
Okay. So the two phases of drying is number one, the constant rate period, and number two, second phase is the falling rate period. And then in the middle of that, there is what we call as the critical moisture content. As you can see in this figure, makita ninyo diri at this is basically the moisture content level, ang horizontal, ang vertical, ang horizontal line, ang kini nga axis is defines the drying period or the drying time. So, during the constant rate period, the rate of the evaporation is uniform. So, more or less linear ang iyang evaporation. So, paspas kayo ang decline sa sa removal of moisture in this level. Through a very short period of time, there is a high rate of losing the moisture content from our aquatic products. Now, if it reaches this point, this level, what we call as the critical moisture content period, there will come a time na moabot na siya sa muna yung gitawag nato na siya sa second phase, which is more gradual ang iyaang pag-remove sa moisture content. We call that as the falling rate period in the phase of drying. So again, falling rate period is there are more barriers that prevent the movement of the water to the surface. Part of that is that the rate of drying continues to decrease and becomes negligibly small as water content of the fish muscles approaches an equilibrium value. So, katong mga smaller moisture or vapors that is being trapped by the flesh of the fish, regardless of what are the other factors that basically hinders the removal of these moisture contents, muna'y nagpa-drive nga hinay ang release sa moisture content at this phase, sa ani nga phase sa second phase. So once again, between the two phases, there is what we call as the critical moisture content. Critical moisture content is basically the average material moisture content at which the drying rate begins to decline. So again, this is basically murag gitawag nato siya na, so kung sa ecology pa, gitawag nato siya compensation depth. So in between the two phases of the the stages of drying. Alright? Now, in the first phase of drying, there is what we call as the factors that influences the removal of this moisture content. Number one of that, or first factor that basically influence the rate of drying in the first phase is the surface area of the fish. So obviously, it is it is directly proportional. So kung dako ang surface area sa fish, of course, paspas ang removal of moisture content. But smaller area or smaller surface area basically slows down the rate of the removal of moisture content. And that's the reason also why most of the dried products are being sliced open, no? Kanang mga daing kung imo na dili na mo na siya pikason, hinay pud ang moisture content removal ana niya. Alright, so surface area, the larger the surface area exposed to the drying air, the faster the moisture content of evaporation. The opposite is otherwise. Okay, so kung smaller area or narrower area exposed to the drying air, of course, hinay po ang iyang rate of evaporation. Second factor that influence the rate of drying in the first phase, katong atong gitawag na constant rate period is the relative humidity of the air. Kagahapon atong gi-define ang relative humidity or what we termed yesterday as the RH, no? Ang relative humidity of the air influence the drying rate of by limiting the amount of water the air can absorb. So yesterday we defined the humidity as the amount of water vapor that a certain air molecule can hold. Now today it is basically the same definition but in the context of food. Okay? So, influenced by drying rate by limiting the amount of water that the air can hold. So, kung yung imong area is high ang iyang relative humidity, of course, hinay po ang rate of evaporation. Whereas, kung dito ka mag-dry sa areas where there is a dry air or there is basically a low relative humidity, paspas ang iyang evaporation because the air molecule can hold more water. So, katong water or moisture content from your products could be absorbed by the dry air nga naa dito sa imong environment. And sometimes, this relative humidity is directly influenced by the temperature. And that's the reason why increasing the temperature lowers down the relative humidity. Kung taasan imong temperature, muubos ang imong relative humidity. And therefore, kung muubos ang imong relative humidity, paspas ang imong rate of evaporation. Okay, so that's second. Number 3 is the temperature. Temperature affects the heat transfer and relative humidity rates. So directly proportional as what I have explained in this and the second factor that influence the drying rate in the first phase is the temperature. Of course, obviously, kung taas ang temperature, paspas ang evaporation. Kung ubos, hinay pod ang rate of evaporation. Okay, so affects the heat transfer and relative humidity rates ang temperature. So, kung taas ang temperature, lower ang iyang relative humidity. Kung ubos ang temperature, higher ang iyang relative humidity. Now, here we have the warm air holds moisture than cold, holds more moisture than cold air. The low relative humidity favor more rapid evaporation and higher drying rates. So obviously that is the case in the principles with regards to the temperature and the relative humidities in the environment. The fourth one in the first phase or the factors in the factors that influence the rate of drying in the first phase, the fourth factor is the thickness of the product. So kabalo na gyud tadaan nga kung baga ang product, hinay pud ang rate of moisture removal. Pero kung nipis ang product, paspas pud ang rate of moisture removal. Just say for example, dry ka og pinikas na danggit tapos mag-dry pod ka og pinikas na tuna. Of course, mauna pag ka-dry ang katong thinner ang danggit na pinikas kumpara katong tuna na gipikas. Alright, so product thickness basically influences or directly proportional to the rate of evaporation with regards to drying. Number 5 is the salt content. Yesterday we had understand the principles of the salt. The higher the salt, the faster the rate of moisture removal. The finer the salt, it will also have negative impact, particularly on the salt burn, no? Natin gitawag na salt burn or reddening. Okay, so the salt content, the lower the salt concentration, the faster the drying rate. Or heavily salted fish will form salt crust on the surface that will reduce the diffusion rate of the water and subsequently the drying rate. So gagahapon nato ni siyang gi-discuss nga kung gagmay kayo mag-clog ang katong mga gagmay nga mga fine salts that will basically reduce the drying rate of the products. Kadot lang kaya naglubat akong laptop. Wait lang kadali oh. Okay, good. So, as what I was saying, the salt content basically influences the rate of drying in the first phase, which is the constant rate period, no? So, obviously, the lower the salt concentration, the faster the drying rate of a certain product. So, I think that's clear. Now let's proceed to the factors affecting the drying rate in the second phase, which is the falling rate period. First factor is relative to the first factor also in the first phase. Number one is the product shape, no? The thicker the flesh, the longer the drying time or the drying rate. So obviously kung ang imong shape will be round, of course dugay pud na siya um, ang shape sa imo ang dried products or i-dry nga product is round, mga bullet tuna, mga unsa pa na dira nga mga klase, and then thicker ang iyang flesh. Of course, longer po ang iyang drying time. Second is the temperature. Drying proceeds rapidly with the increasing temperature. Kung taas gyud ang temperature nimo, obviously dali ra pud kay na siya mag-dry. Now, we have here in the campus the drying oven. You could set the temperature at a certain level and you could set the time kung kanus ano mo siya tama ni off. So, pwede na mo siya biyaan and then later on, mag-alarm na kasi mo ang phone and then kung mahuman na ang drying period, pwede ninyo i-assess kung pila yung final weight so that you could assess the moisture content. The third factor that influence the drying rate and the falling rate period is the relative humidity as well, no? Drying rate changes with relative humidity but is only significant when the other factors when the other factors basically influences the environment also. Like for example, ang imo ang giprocessan og drying process is taas ang humidity, no? Taas ang relative humidity. So obviously, ubos po ang imo ang drying rate period. Same kagahapon nga atong explanation. Kung the higher relative humidity in the environment where you process your products, the rate of the salt penetration could also be hampered or slows down. Mahina yung imo ang salt penetration. Why? Because ang product or ang salt, katong kagahapon nato na example, ang salt will tend to acquire moisture content from the environment apart from acquiring the moisture content from the product itself. Okay, so relative humidity is basically inversely proportional with regards to the rate of the evaporation. Okay, so that's third. And the last one is the salt content. Obviously, yesterday we have already defined the relationship between the salt content and the drying process or the removal of moisture. So the salt content is basically the same way or the same action from the salt penetration yesterday. Salt content are more concentrated salt solutions remove more water by osmosis. So obviously kung wala siya yung mga impurities, paspas po lang iya ang mga moisture removal. Evaporative drying required short drying time for strongly salted fish. And there are cases that salted fish will tend to suffer from what we call as katong gitawag nato na salt burn or katong mga dun or reddening na mga products. If I may still recall unsa pa tong causative agent, kinsa may maka-answer sa ko unsa may causative agent sa dun spoilage? DUN. Anybody?
Halophilic molds or ang species dito, sir.
Ang species sa genus, ang genus sa dun. Di ba ang dun are molds? Unsa man siya na genus sa molds?
Atong Walemia, sir? Walemia species?
Walemia species. What about the other spoilage of salting, katong reddening or pinking? O naman tong duha ka species sa kuan, bacteria.
Ano, sir? Agad, sir. Dito mo na sa Linaria, sir.
Ha?
Dito mo na sa Linaria.
And then
Sa Arsena lateralis.
okay, very good. Namate basa ka jud. Sige, marajaw kay nadumduman. Here in this module, naputay lahi na pod na mga factors that basically results to spoilage, no? Part of which are katong gitawag nato na mga reddening or pinking. So parehas lagi hapon nga tawag more or less, but basically involved in the drying processes or principles. Okay, so now here are the types of dried fishery products kanang atong ipang tawag na mga bulad, no? Dried in round or whole fish or gitawag sa Tagalog na tuyo, no? Commercial tuyo it has a moisture of 40% maximum moisture content. So more or less kini siya nga mga level are prone to mold attacks and halophilic attacks, no? Kani siya nga mga level of moisture content. Kasagaran makita nimo nga mga bulad labi nakabox daghan kay na siya lag mold sa usahay. So, recommended salt 12% recommended. The water activity is for about 0.78. Histamine level of 60 milligrams per 100% edible portion of the flesh. So, that's the first type of dried fishery product. Second type are daing or split salted fish. So, mangutana ang inyong amigo niya. Sudan ninyo daing. Ano yung sudan? Split salted fish. Diba? Grabe ka, social. Okay, so some of the split salted fish are bisugo, mackerel, milkfish, rabbitfish, scads, and you need to take a look at the physical-chemical requirements for the commercial fishes. Same to that of the tuyo because more or less the levels of the dried, round, and split salted are more or less the same, especially if the processor applies the same method or the same procedure. Okay? Another type are the dried anchovies. Mga dried, ano pa yung ngayon sa anchovies diri? Sa kuan? Siargao? Ano yung ngayon sa mga bulinaw?
Bulinaw, sir.
Bulinaw eh. Na yung wilayin nga ngayon na to.
Dumodot, sir.
Dumudot. Dried dumudots. So, amo dyan sila. Number 4, another type of dried fishery products are fish jerky, a dried snack products. So, if you search this fish jerky, you could basically say that murag siya mga tofu, mga nga na. And then dried squid, mga products nga mga mollusk, mga dried also are under this category. Okay, so these are basically the dried products. And now let's proceed to the methods of drying. First method is the air or contact drying. The heat is transferred to the fish from the heated air, and in the Philippines, sun drying is very practical or traditional manner of air or contact drying. As long as dili gid nimo siya kanang makita ni ganis mga daplin, dili na siya advisable nga gipabulad na sa ato, gipamulad lang sa daplins dagat, pangbulad lang des mga boulevard, dili na siya advisable. It should be covered with mga nets or whatsoever because the kanang mga insects, mga flies, mga langaw, kung mutugdo na sila dira, grabe kapaspas ang reproduction sa ilang mga kuan, sa ilang mga eggs. So kung makatugdo ng langaw dira, makaitlog na siya, and then katong ilang mga itlog will grow into maggots. Kailangan ng mga maggots, di ba? Kanang mga ulod. So, that's the reason why, kinahanglan kung mag-dry ka, dapat timingon nimo nga suga gyud kaayo kay kung mag-dry ka tapos magbulad ka tapos walay suga and then ma-prolong ang imong pagsuga, the higher the drying or the longer the drying time unya dili kayo intense ang siga sa adlaw, there is a tendency that your product will develop a mold growth, no? Katong parehas atong akong nag-process ko, nag-laboratory ko sa ako ang feed formulation. Because the products or the ingredients are high of protein, no? Taas kay na siya protein content. Katong akong mga feeds nga gi-process na ko siya Friday. Kay gusto na ako makasugod kog experiment by Monday kay para maapas na ako pag analyze and then maka-print kog hardbound sa akong thesis. So what happened was gibutangan na ako ang akong feeds. Gi-dryer na ako ang feeds inside the laboratory. Now, ang sulod sa laboratory na siya recirculating system, na siya mga water, daghan kay siya mga daghan kay siya mga sources of evaporation. So, more or less, taas kayo ang relative humidity dito nga area. So unsay nahitabo sa ako ang feeds nga gibulad or wala na ko siya gibulad, gibutang na ko siya sa lamisa. And then gibiyaan ako siya for a weekend. And then ingon ko nga basig lamigasuni pag-abot sa Monday. Ang gihimo nako, gibutangan ako mga water ang mga tiil sa lamisa para dili makasaka ang mga lamigas. Pero pag abot sa Monday, pagbalik na ako sa laboratory, nagmolds na nga ako ang mga feeds. Wala ko tod siya gilamigas pero naggrow ang mga molds because the room is very high in relative humidity. Taas ang moisture content. Tapos na prolong ang imo ang drying time and then hinay ang intensity sa imo ang light did mo attack ang mga spoilage organisms katong mga molds. Now dili to na ako magamit nga mga feeds na dayon so ilabay na nako to kay kung ihatag to na ako sa ako ang mga shrimp mapatay pud ako ang mga shrimp. So those are the factors that you need to consider, no? Kay you could not always foresee the things that will happen in the future, especially when you do experimental research, no? So that is with regards to the air or contact drying. And then second is vacuum drying. Uses conduction by contact with the heated surface or radiation to the surface of the water removed by vacuum pump. Allows the rapid drying at low temperature resulting a greater retention of nutrients. So, kung paspasingin mo ang rate of the drying period, ay taas po nga tendency nga that the nutrients, the protein content, the minerals and vitamins are still present in that particular dried products because if you prolong the drying period, there will be a tendency that these minerals and vitamins will be dissipated in the air, no, dissipate ra na siya or sometimes be broken down. Okay, so that's second. Number 3 is freeze drying, no? Freeze drying depends on the attainment of the very low pressures by highly efficient vacuum pumps in a sealed chamber containing the product. The fish freezes in contact with the refrigerated plates. Same goes with the katong hot plate drying, hot plate freezing or plate freezing katong sa nauna na itong i-discuss. Nga mag-touch ra siya sa plate and then it will froze out. Okay, so freeze drying po na siya. Gina-dry siya through exposure to very low pressures and temperatures. So below 0.64 kPa ay sublimes and vapor is removed from the fish product by vacuum pump. That is the principle of these two, vacuum drying and freeze drying. So those are the three methods of drying. Now let's proceed to the spoilage. There are 4 spoilage actually. First spoilage is case hardening, second is mold growth, third is reddening, and fourth is insect attack. Mga spoilage and defects of the dried products. Now let's first take a look at the case hardening. From the term itself, case hardening, bot pasabot, ang outside nga part sa fish is being hardened. Manggahi na. And then the middle portion still has its moisture. So, it is technically defined as, it is a result of a rapid drying. Kanaganing grabe ka, kusog ang imo ang pag-expose sa iya sa very low temperature. Kanya, ang sa gawas, nanggahi na, mura na siya bato, pero ang sa sulod ay ito, napay mga moisture contents. So, rapid drying. Drying of the outer portion of the fish. So, basically, kining area is na dry na, pero ang sa sulod, wala pa. Na-trap siya sa dry products. Makita niyo yung picture, no?
Yes, sir.
Okay, so these parts are basically hardened wherein the moisture content inside are being trapped. We term that as case hardening. Second type of defects or spoilage is the mold growth. So mold growth specifically katong gi-term gahapon nga molds caused by Wallemia species, no? Mold growth due to the high moisture content usually caused or brought about by black, blue, or green molds. So you could detect molds from the white patches or kay mga puti-puti nga murag mga gapas mo na mga molds. So this is what happened in my feeds katong nag-experiment pa ko na daghan kay molds ng grow. Okay, so you should avoid high moisture content of your product and expose it to a very long period of drying. Third one is the reddening, the growth of red halophilic salt-loving bacteria where impure salts are used. So kagahapon mo ra gihapon ni siya nga suffering or defect. Number four are insect attacks, no? Can be prevented by proper packaging. Kung imo na siyang ipack pagtarong, wala gyud air nga makaduol sa iya from the outside environment. And then you could also do dipping before drying in a dilute solution of the odorless insecticide, pyrethrum, or light dusting from the product with the dried substance. So imo na siyang sabuagan og pyrethrum, pwede na kay dili man siya manimaho kay dili man po na siya toxic, pwede na mo siya i light dusting mo na siya og i-sift nimo siya sa isa ka strainer or sayahan tapos imo na siyang dust ra nimo sa ibabaw. You could also do fumigation of spaces where dried fish is stored, no? Before nimo siya butang dito, mag-fume sa ka, mag-apply kag mga pang-prevent sa kuan, sa insects, and then ayaw po di butang dito dito ang imo ang product tungod kay mag-settle po tong mga fumes dito sa imong product. Okay, so those are the ways, those are the defects and the ways to prevent to this kind of spoilage. Now, here we have the steps in drying. Wash the fish thoroughly, of course. Soak the fish in a 10% brine solution for 30 minutes to draw out the blood. Squeeze or open the belly cavity, remove the visceral or internal organs. Soak the fish for 3 to 6 hours in a concentrated brine solution to partially draw out the moisture and water content of the fish. Fifth step is place the salted fish in a drying trays and dry it under the sun or under the mechanical oven. When the fish are thoroughly dried, pack them and store them in a clean, dry place. So in our case, kay magkuan man ta, laboratory man tag drying process, siguro you will no longer need the drying in the sun. I will talk to surgeon siguro kung unsaon pag kung pwede pa ta mag-anhydryo niya, magamit ta sa oven dryer. And then magdala lang mo imo inyong product daan nga nahuman na tanan nga steps, ang 1 2 3 4 nga steps. Tapos ang fifth step will be done here in this campus kay para dili na mo mag paabot kano sa maugang inyo ang product, especially nga dili permenti suga. Okay, klaro?
Okay, sir.
Okay, so I will just notify you when will this arrangement be available. Okay, so okay, end of module 6. I think that's all for this module. Any questions? Questions? We are only 7. 6 na lang ta. Questions? Wala na yung questions? Wala na ilo ang uban? Wala na yung questions? Actually, kung na may questions, pwede po ninyo ipangutan na dito sa group chat. Okay? So, again, thank you very much for joining sa aning session today. And perhaps we'll see each other again on Friday. Or, yes, sa Friday siguro magklase na po ta about smoking, or sa Tuesday. I will not be available on Monday. So, again, thank you for joining here sa kaning session. And if you have any questions, you could ask me through the group chat. Okay? So, salamat.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.